My mic.
Hello.
What's up? Can you hear me, Ben?
Yeah, it's been going good.
All right. Good afternoon, Madison.
Afternoon.
All right. Can you guys hear me okay? It sounds like I'm having audio problems.
It's fine.
Okay.
Yeah, it sounds.
All right, here we go. So I don't know if Ben and Madison, you've taken your test yet, but all the kids here took their test yesterday. But make sure you have your test done by today. We are moving on. So what I do after, I always do it after chapter 5, is that we're about a month and a half away from semester finals. So I do like, let's just do a quick look back on what we did the last 4 chapters. So we'll do this again when we get past chapter 8. I'm sorry, 7, 8, 9, after 10. After chapter 10, we'll do this again. So we just do a quick review back. You are not going to be impressed by today's class. It's not anything, but tomorrow maybe, review a bit more meatier material, but today's just a quick view. So what I'm going to do is I'm going to pass the clicker off, and you have to say something about every slide or every click of the slide. And then we're just going to pass the clicker around. And then you got to say, you got to talk loud too. So Madison and Ben, and then Madison and Ben get a turn as well too. So it's going to be a review sheet. Ben and Madison, it's already online for you right now. And here we go. That side, Mikhail, you got to be loud.
I don't think that's going to be a
The
problem.
clicker is this one that's not marked. So that's the forward, this is the back. So one click, and then you got to say something.
Birds. Point.
No. One click. All right. What do you got there?
It's a point in space and time.
So give me your definition of a point.
A location, a point that has. I don't understand. A point is a location.
Don't click it again.
Okay.
Just say as much as you can.
A
without
point
clicking.
is a
Well, you've already
location.
clicked it once. So go ahead and show the definition. All right. So a point is a.
Location, a place that has no. A point has no.
So is it a physical thing, or points physical things?
No.
No, they're just coordinates of a point in space. That's it. That's what we define as a point. All right, hand the clicker. All right. How do we name points?
I didn't do laser.
The laser is the green button. Isn't there a green?
No,
Oh.
it's on the front. The line.
All right. So how do we name points?
By capital letters.
Click. Click one more time. All right. Pass it. All right. You click it once. I'm not sure what will happen. We'll see. And you guys have to talk now. Okay. One more time.
Space.
Space is the collect. This is the one that. Okay. I don't think I had you write this down, but if you take all points that exist and you put them together, that's what makes up space. Okay. All right. Click it again. One more time. All right. If you have a point, we'll call it
C-A.
click.
C.
And you have click.
Another point.
Okay, now you got to finish.
Then you connect them,
A little bit louder so that they can hear you.
If you connect them, then you have a line segment.
So what's the definition of a line segment?
2 points connected.
2 points connected. The line in between.
It's not a line.
Oh, a segment.
Well, we're defining what a segment is.
Oh, a segment is the thing between the 2 points.
What would that thing be?
Whatever this is, a line like thing.
Really? That's our definition. Segment is the thing between the two things?
The distance connected.
Well, that
between
would be
two
a
dots.
physical measurement of it.
All right, the connection between 2 dots or points.
Well, I can connect them with a curve.
The straight connection between 2.
All right, go ahead and click.
Uh,
All right. It's a part of a line that connects 2 points. Okay. All right, hand it off. All right, how do we name segments?
With a line over the letters, you do both of the letters and the line.
Could it be any of the letters on the line segment? No.
Only the 2 endpoints.
Only the 2 endpoints. Click. You can click it a couple times.
Wait, it said can be named by any 2 points online.
It should say the 2 endpoints, because if it's any 2 points, a line segment can be named by any 2 points on. Yeah, that's wrong. I wonder if that's the way I had it from the thing. So it should be, can only be named by the 2 endpoints of the segment. This is actually the definition of a,
Line.
that's a definition of a line. Any 2 points on the line define that line. So a line segment must be named by the 2 endpoints, is what it should say. Okay, pass it.
Couldn't it technically, if there was like a C point in the middle, couldn't you do A, C? and then
You
C?
can, but would that be the same segment or a different segment?
It'd be a different segment. That's the
Right.
point right there.
Now, if it was a line, what you said is right. Any 2 points. All right, pass it to McKinley. All right, Ben, you're up.
Pass it down.
What am I going to say about this slide right here? Don't click it, McKinley.
What slide?
The slide that you see right now.
I don't see a slide.
Are you looking at the back of the chair again? You guys are supposed to tell me this. You're not supposed to sit there for 5 minutes and say, Mr. C, all
Well,
I see
actually-
is you. Boy, how's that? Better?
Okay.
All right.
Um,
All right. we're
I
listening
can
to
tell.
Ben now.
I can tell you about line XY.
Like a cat.
What?
Line XY?
Line segment XY.
Okay.
Line segment XZ. Line segment YX. Line segment ZX. Line segment ZY. Line segment YZ.
So how many actual segments are there?
6.
You guys agree? They're all agreeing with you. I don't agree
No,
with
no,
you.
there's only 3. There's only 3.
Which 3 are there?
There's 3, but then there's 6 if you inverse the letters.
Well, that's the same thing.
It's the same segment, it's just different names.
3 more times. 1, 2, there we go. Stop. Go back. All right. So yes, that's the point we're making there, is that any segment that has 3 points on it, McKinley, any segment that has 3 points on it, you actually get 3 segments out. And that's not a rule of 4, you get 4, that sort of thing. But for this particular one, when you have 3 points, you do get 3 unique segments. And each segment can be called 2 different ways. So there's 6 names there, but there's really only 3 segments. All right. Madison, what's the shape?
She can't see the laser.
It's a laser. It's cool.
Madison, what's the shape you see here?
A line?
I kind of hear you, but I don't hear you. You got to talk to your microphone.
A line?
Okay, is that a line?
No, a line segment.
Okay, so you see a line segment. What is the name of that line segment?
Line segment AB.
Click, click. All right. If we were to measure that line segment with a ruler, Madison, how would we write the measurement? Let's say it's 6 inches long. How would we write that answer?
A measurement of line segment AB is 6 inches.
So we could certainly use words. Now, if we want to use symbols, how do we do it? Like you see how we have the name on the slide? It's segment AB.
Uh-huh.
Could we write segment AB equals 6?
Yeah.
Okay, but we would have to do one thing in order to do that. What do we have to do? That's different from a name. McKinley, what's the answer?
The AB, 6, BA. It's BA.
That what?
BA, that's still a line.
How would we write if it's 6 inches long? How do we write that?
Oh, okay, line segment AB.
That's what Madison said.
Well, that is how you do it.
That is not how you do it, unless you were using words.
Oh,
If you want to use in word form, line segment AB is 6 inches long. Absolutely right. Jack, what's the answer?
If you take out the line on the top, it's just
Click.
Click.
So, Madison, this is how you write a measurement of a segment. You have to take that line segment over the top. In fact, the only symbol you get to use with the symbol line segment AB is, what's the only symbol you get to use with that? The congruency symbol. So if you leave that little line segment on the top of it, the only symbol that goes with it is congruency symbol. Turns out you can put many symbols next to AB. Right now, all we know of is equal, but this next chapter, chapter 6, we're going to use greater than, less than as well with it too. All right, click. All right, McKinley, how do we draw a ray?
Okay, so put a dot right there,
Click.
then put it, make a line there.
Click.
Just an infinite. Like that.
And what else do we need?
You can put another dot on it,
Click.
and you get a ray,
Well, what's the name of that ray?
XY,
Why isn't it YX?
because it's not a ray that way.
Okay, so all segments must be named.
Yeah, all segments are all
I'm sorry, all rays, sorry. All rays must be named.
XY,
No,
not from right to left to right.
no.
No,
Because what if you have a ray going that way?
well, you can't have a ray go that way.
Yeah, you can.
That's never been an example we've ever used.
Well, there's about to be one on the slide.
Like this way and this way.
It has to be from the beginning point
Except we actually call the beginning point
the start. Vertex.
no. We actually call the beginning point, not the beginning point. Paradoxically, we call it the,
Endpoint.
so rays must go from
End point to whatever.
to infinity, right? Click.
I don't
All right,
understand.
so that is ray XY with the symbol XY. Now, notice that the symbol points to the right and this ray points to the right. Is that always the case?
That's always
For
ray.
for
For this type of ray.
for the name of the ray will always point to the right. But the ray itself can point in any direction, but the symbol will always point to the right. All right, hand it off.
I don't want to hand it off.
All right, one click. All right, not YX. All right, one more note. So there is your example, McKinley, of a ray that actually points to the left. And guess what the name of that red one is? It is still, click. It is still XY, even though it points red. All right, one more time, Jack. Interesting fact. You've probably forgotten this fact. There's lots of rays there. Jack, give me a couple of the rays.
X, Y, Z, X, Z, Y.
Okay, give me 4 clicks. 5 clicks. One more. Now stop. All right. There's something interesting about.
Oh, yeah. Y, Z. And there's Y, X as well.
There's something interesting about click. Those 2 rays. Tell me what's interesting about those 2 rays.
Oh, I remember this. It's like they're like intersecting at one point, kind of. They both start at one point. So like a
2
chain of
clicks.
rays or
2
something.
clicks. There's something interesting about those 2 rays. Now, granted, I drew one above other, but I am talking about XY and XZ. What's the name of those 2 rays?
Those are adjacent rays.
That would make sense,
Um,
but it's not what we call them.
sharing rays that make a line.
And those are 2 rays that do make a line, but we have a name for that.
Line ray. Linear ray.
Now, I'd go with that.
About
I said you'd probably forget this.
X, Y, Z line.
Anybody? The rays point in,
Opposite direction.
Oh,
so they're called
Opposite rays.
click. So those 2 rays, click,
Jack, quick.
Line.
those are called opposite rays.
I like
All right,
when you
hand it off. All right,
point.
do you remember postulate 2?
Yes.
This is her question. What does it say? Okay, 1 click. All right, one more click. So what does postulate 2 say about this segment?
AB or
It could be, but we don't know.
AB plus.
Okay, I'm not sure that Ben or Madison could hear any of that, but she said that AB plus BC equals AC, click. And a couple clicks. That's what she said. Okay, and that is true. So that is the segment addition postulate. And now we've arrived, this is still chapter 1 stuff, we've arrived at the first actual skill that we have. And we can do calculations based upon this segment. Pass the
Congruency, that's what's next.
All right. Click. So basically it says that piece plus click that piece equals the whole darn thing. And they're two different pieces and two different measurements. All right, one more time. Click. All right, so this is your problem. If we want to be very, very, very meticulous and wrote this out instead of just writing the answer, we would write. We want to write an algebraic equation. What will we write here? Well, how about with the names?
12.
Let her answer her question. Okay, so for those of you that couldn't hear it, she said ST plus RS equals RT. Click. Okay, I wrote the same thing. All right. Now, if we were to plug in the numbers, which would go where? Click. Therefore, the answer is
I'm correct.
click. Okay, good. All right. All right, Ben, you are up. This is a challenging one because we have we got 4 points here. So Ben, how would you do this one?
Okay. Well, we know that from line D to line G is approximately 17, is not approximately, it's 17 units. And we
Okay.
know that from D to, from ray FD is 9 units long. And if we want to find EG, well, then we take the 17 minus the 9, so we get 8, and then we add it to 5, add 5, because we know segment E, line segment EF is 5. So 8 plus 5 is 13, and that makes sense with ray ED is 4. So yes,
Okay.
13.
And if you really want to be meticulous about it, since it's asking for EG using postulate 2, if you're trying to find EG, well, we know that EG is equal to EF plus FG. And Ben said he already knows that EF, because it's marked as 5. So the question is EG, which we don't know because we don't know what FG is. But we do know that all in total, that DG, which isn't part of my equation there, is 17. And further, we know that DF is 9. So that would leave 8 for the total, which has to be the distance of FG. So using those 2 points right there, 5 plus 8 is 13. He is correct. Okay? Yeah. Well, 17 minus 9 would absolutely. But if I want to write it with, and that's what I would do, absolutely. But I'm saying if I want to write it with what it's asking me to figure out, how long is EG? Well, then you got to write it. It's a combination of EF plus FG. So no, I would not literally solve it like this. But if we want to write mathematically what EG equals to, then we got to use that postulate 2 to do that. And that's what we would wind up with. So yes, you were right. All right, Madison, what do you think I'm going to show you with this slide? Madison,
Yeah,
what do you
sorry.
think I'm going to show you with this slide? What do you notice that the 2 rays have in common?
Point B.
So if we were to squeeze, oops, sorry, wrong way. If we were to squeeze them together, we make a,
Go.
okay, so Madison, what's the definition of an angle if this is how it's formed? And I'll help you out. An angle is a shape that how did we make that shape?
By intersecting the lines.
Those aren't lines.
Intersecting the line segments.
Those aren't line segments.
The points.
Well, what are they to start with? Look at them. What shape is it? It starts with B and it goes to the right forever through C. That is what? Is it a segment, a line, or a ray?
Array.
So an angle is formed by
2 rays.
that intersect each other at a common point. All right, so that's the definition of an angle. It's a figure or a shape formed by 2 rays with a common endpoint. All right, Madison, what's the name of this angle right here? Who's got the clicker?
Why so irresponsible?
What's the name of this angle, Madison?
An acute angle?
Not the type, but what's the name of it? Like just, you know, we had segment AB. What's the name of this? What's the name of this angle?
Angle ABC.
Is there another way of naming it? First click, somebody. Is there another way of naming it?
CBA.
Click. Is there another way of naming it?
No.
For this one and only this one, because it's floating there all by itself, we could also call this one by its vertex name, therefore we could call it angle B. And there's a fourth way of naming it, and that's if the angle has a number, we can call that one angle 1. Okay? Madison, yes?
Yeah.
All right, McKinley, you're up.
Yes, give me the clicker.
All right, 1 click. That is,
Angle B.
now if I were to take a protractor and I were to measure it, we find out it looks like obtuse to me. It looks like it's about, I don't know, 160 degrees.
Yep.
How do I write that?
Angle B is equal to 160.
Yes, no?
No.
No. How do you write if you want to say what its measurement is?
Angle B. Grew into one. No,
Mhm.
that's not right. Oh yeah, M measurement equals.
Click. So if we want to talk about the name, it's angle B. Click. If you want to say how big it is, then you got to write it like that. That means the measure. 1 more click. So 134, whatever the measurement is. All right, hand it off. Good Lord, you're like a baby Yoda in the throttle quadrant of the ship. All right, 1 click. All right, explain it.
You get the adjacent angle. They share a vertex but no interior point.
Explain it.
Angle EFET is adjacent to angle DEH.
Click. Either way is fine. Why are they adjacent?
Adjacent because they share one side.
What does it mean, no interior points?
They don't share any points on the interior.
If you have 2 angles, online people can't see, I'm holding up my fingers with 2 V's. If here are your 2 angles, and you put them together like this, they are adjacent to each other. If you put the 2 angles like this, then you have, between my 2 fingers here, you have interior points on both angles, this point right here, that are now shared between the 2 angles. And you don't have a line. You got a W, or a really weird looking W instead of that W right there. Okay. Hand it off.
It's a laser.
All right.
How did you not laser it?
All right. If you have an angle, click, and you cut it in half, 2 clicks, what do we call line array OB? What kind of bisector? Click. So that's what's called a bisector of an angle. A bisector of an angle is not another angle. Only it forms 2 angles, but the actual bisector is a ray. When you bisect something, and it could be a segment as well too, but we stick to a ray. That is either a line, a ray, or a segment, but in this case, we're going to say it's a ray. Okay? So that's the definition of an angle bisector. It cuts a given angle in half. Hand it off. Click. And now we arrive to our second skill. Remember, postulate 3 was the protractor postulate, and postulate 4 is the angle addition postulate. So tell me what you're going to say about this slide. She said COB plus BOA. And McKinley, we got to add one thing to what she just said about COB and BOA. We're talking about pluses and equal symbols. We must put in front of all of that stuff an M. Click. Okay, another click. So without the M, technically you can only use congruency symbol. With the M, you can't even use the plus. Correct. Okay, so if you're going to use pluses and equal signs, that M's got to be, then that's only for angles, not for segments, obviously. All right. Ben,
Yes.
what the heck is that?
That's really strange. It seems like two angles, when you add up their measurements together, they equal 180 degrees.
Because we know the measurement for a straight line is 180 degrees. Therefore, these are called linear pairs. All right. Well, by definition, remember we decided that a straight line has 180 degrees by definition. So the proof part was not necessary because of the definition. Well, I mean, it was necessary, but we never proved this one because by definition that's true. All right, Madison, you get the first really ugly one. So to do these right here, I mean, it ends up being a pretty simple problem. To do these right here, you just got to read it carefully, closely, and fill in the blanks when necessary. For me, I immediately look at the question. What's the question asked, Madison?
Find measure of angle EUV.
So for me, I trace that out with my pencil or pen or something like that. So for me, what I end up doing is I take my pen or my pencil and I say, well, where's EUV? EUV is right here. So I'm trying to find this angle right here in blue. Okay. All right, so Madison, what are we going to do? Using postulate 4, which is the angle addition postulate, we can immediately say what? What does the angle addition postulate say, Madison? She's still here. Madison, can you hear me? Madison, everything is turned off.
I'll unmute her with this touch screen. Blue light.
I've lost my mouse. All right, so I'll take over. So there's my mouse. So this is what it says. It says that the angle addition postulate says that VUE plus TUE would have to equal the whole thing. In other words, TUV. Now we take our given information. We're given that TUE, this part right here, TUE is 120 and TUV is 162. If we really wanted to set up an equation, we could. Therefore, algebraically, we need to do what? Subtract 120 from both sides. Therefore, we get the measure of angle EUV is 4.2. Madison, when you finally get linked back on, give me a shout out so I can tell you're back up. All right. Oh, I got to clear that. All right. What's that mean, McKinley?
Two angles that equal 90 degrees.
Okay, so for instance,
This thing,
a right angle,
a right angle,
okay?
or whatever this angle is.
So could you draw me a picture of that on the board without the laser pointer?
I'll take the laser pointer. No, I think I'll keep it.
McKinley,
Oh, what? Yeah,
draw me a picture of complementary angles.
compliment.
That's what it says.
No, that's.
That says complimentary. We already did something.
We haven't done
Doesn't mean they
supplementary.
make each other are pretty.
We've done an example of supplementary. Just draw me a picture of complementary angles. Are you drawing? Is that Sanskrit or something?
It says two angles.
It's just this is less than this is less than this is. less
Oh,
than this.
you mean two angles? Okay, that makes more sense.
Only one of
erase-
those angles actually equals 90.
Okay, now how do I know those are complementary? The way you drew them. How do I know that?
Because this equals 75.
Wow.
And that equals 75.
Oh, they're not complementary then.
What equals 90 out of this?
Why don't you pick easier, friendly numbers?
75 plus 50.
One
Very
equals
good.
75, the other is 15.
Thank you.
Is there an easier way to indicate that they're complementary?
Look at the
Congruent
Just
lines?
drop off.
yeah, like the
You mean the arcs?
yeah.
Well, then they would be congruent, right? But
Not what I meant.
that wouldn't mean that they're complementary.
Draw the 90 degrees.
If you drew the 90-degree symbol, then you're guaranteed that both angles are complementary. Now, further, if you want to do her idea, which is using the little arc thing, then we would still have to have that 90-degree symbol because that's what makes it complementary. Okay? So if you wanted to show that both were 45 degrees, you could. All right, 2 clicks. And erase the board so that we can not have a headache.
Not working.
2 clicks. All right, right. Now go back 1 click. Okay. The other way that you get complementary angles, if you still have just 2 angles just floating off by themselves, for instance, in a triangle, and they're labeled, erase everything, McKinley. In this case, 45, 45, then you know that you have complementary angles right there.
You know the other 90. You know it's right.
Well, I'm not talking about the right. So yes, for this particular, we know it's a right triangle, but the bigger point there was the fact that you could have 2 complementary angles that are not adjacent to each other. The first one we all think of adjacent, but the second one, they can still be complementary, just not adjacent to each other.
Under the A.
Under the A. Oh, yeah.
All right,
You have a point.
supplementary, pass it off.
Oh, yeah.
All right, Jack, draw me a picture.
This equals this, and this equals that.
I don't know why you guys are so against the laser. The laser was the best thing that ever happened.
McKinley, if you can tell me what laser stands for, I'll give you a chapter of no homework.
He's on the spot.
Don't put it in anyone's eyes.
Ow.
What does laser stands? It's actually an acronym.
I know. I just can I get it back to you tomorrow?
No, because anyone can Google it.
There's a computer right there.
I'm gonna let you take a wild guess at what the L stands for.
Laser.
No,
Line.
Line.
no.
Laser.
Light.
Light.
Like,
That's literally what a quote unquote laser is. It's a small beam of light.
No.
Well,
The
not
H stands
exactly.
for light amplified.
systematically.
Lightly amplified mom.
No.
No.
But it's no M.
Light amplified
Oh,
by
yeah,
the stimulated emission of radiation is what it stands for.
I was making that.
Can you give us another acronym? IDK.
That won't happen. All right. Before Jack, turn around, Jack. Before Jack erased what he had an example of. Do it again, Jack.
Somehow you made my eyes big.
Let's not be shining the laser in people's eyes.
I don't want the laser shine in my eyes.
So he's drawing something that looks like this. So you have a line and you have a ray coming from the line. His actually looks not like what I just drew. His looks more like, oops, eraser. His looks more like this. And this is your classic angle 1 and angle 2 are supplementary. Okay, pass it.
No, Jack, don't let Allie take it. Allie will try to hog it.
All right, there's my example. There's another example more recently from the chapter we just finished, a parallelogram. Any two consecutive angles on a parallelogram are supplementary. All right, guess what I'm doing here?
To the back.
Why do I never get the
What?
or vertical?
All right, so what's so special about vertical angles?
They're congruent.
Click.
They're not parallel, they're congruent.
Yeah, they're
All right.
parallel, they're still parallel.
Just remember they're formed by two intersecting lines, rays, segments, or any combination of those. And it forms at least 4 angles, right? We haven't talked about the other angles that it forms, but we'll just consider the 4 major angles right there.
They're perpendicular.
Well, they could be perpendicular, but they don't have to be perpendicular. Angles are not perpendicular.
Well, it still makes sense.
All right. So we said that, and remember I said that it's more appropriately, or at least it's more descriptively named as angles that are opposite each other when you have when you have an X formed. But yeah, they are called opposite angles. They're called vertical angles, and vertical angles are congruent. Now you have to be careful, right? It's easy when the picture looks like this. It's very challenging when it looks like this. And so how do we make the second one less challenging?
Eliminating 2 lines.
Well, that's one way of doing it. The second way of doing it is just tracing it, right? Literally taking your pen and tracing it out. In other words, if I want to find out what's vertical to 3, then all I'm going to do is I'm going to trace out the 2 rays that make angle 3 and continue them past K. That's horrible. But we can see clearly that what's vertical to 3 is, that one isn't too hard, but I'm saying, I want you to look at angle 2. What's vertical to angle 2? Absolutely wrong.
5, 4.
Oh, no, what did you say?
I said 6.
Oh, I'm sorry. I was looking at 4, and you said, never mind. Yes, a more challenging one is 1.
5 plus 4.
5 plus 4, 4 plus 5.
Angle GX.
Or GK. Yeah. All right. So, yeah, so you guys weren't tripped up by that one. But why does my mouse keep disappearing?
Instead of using that adorable,
No, we won't be doing that. Oh, this is going to be painful if I can't find my mouse.
why you have that, I'll measure how big that means. But the protractor, because I don't feel like grabbing it. All right, let's see. So, it is 90 degrees from there to here. It's 90 degrees from there to there. What? Its wings is 90 degrees. You don't measure things in angles. You measure things in distance. Well, I'll show you the angle. What's the angle? How do you do an angle of a bead? Huh? You don't.
You don't.
You can. Look.
You can measure the
All right,
angle
tell me
of
the circumference of the bead.
All right, I got my mouse back. That's weird that it disappeared like that twice.
Yeah.
All right, sit down.
All right, I'm back to my.
All right, Madison, are you back with us?
Yeah.
Okay, so here's a more complicated drawing. Our goal here is to find the measure of angle 2, 3, 4, and 5. We are given the measure of angle 1 and angle 6. Okay, so tell me what you're thinking.
Well, measure of angle 4 and 3 are opposites of angle
4 and 1 are
30.
Because they are vertical.
Yeah.
So if 1 is 30, then 4 is vertical, so it's 30. What else do we know?
Measure of angle 6 and 3 are the same.
So 6 and 3 are exactly the same thing because they are vertical. So the big question now is, what are we going to do for angle 2 and angle 5?
Since 2 is on a line, it's 180, and 110 plus 30 is 140, so 2 is 40.
Couldn't have said it
And
better myself. All right.
5 is the same.
All right. So we get 40 and 5 is the same. All right, very good. Couldn't trip you up. All right, believe it or not, this is the last slide, and there is a mistake here, not on the picture, but on my answers. I didn't change it from the last period. All right. So who do we leave off on?
Yeah, it's my turn.
Anna never went. Anna, because of the previous time when I said you're up and she didn't answer. Okay. All right. So the first one, angle B, is whatever 90 minus 55 is. Right. And I don't know what I was thinking when I wrote that, but clearly that is the wrong answer. All right. And even period 2 figured that one out, that I had written the wrong thing. All right. So ignore those. The answer is what? 20 or 35. 35. All right. McKinley, middle one, angle B.
Middle one. That's not the middle one. You just have to subtract 180.
You wouldn't subtract 180.
You add one.
You wouldn't add 180.
Subtract 90.
Where do you see a 90?
There isn't. It's just 113. There. Yeah.
No.
Well, you have to add. You have to subtract 180 from that problem.
No, you don't do that.
But why not?
I want you to think about what you're saying.
Oh yeah, 113. 113 minus 180.
So say it correctly this time.
180 minus 113.
Okay, can you do that in your head?
No. I'll see. All right. Don't help me. 10, 7. 4.
What?
47. No. I told
McKinley, here's the way I know you're literally trying to transpose that in your head and like set up with, in line. Here's what I would think. 113 is awfully close to
110.
110. So how do you get from 110 to 180?
3. No,
What?
60.
What? 110 to 180,
70.
right? And it's just 3 less than that.
Oh, 67.
That's how I would think it, right? All right, last one, Jack.
That's harder.
She doesn't need the laser pointer for this.
I want to look at your B is congruent to 88.
B is what?
B is congruent to 88.
B is what?
B is 88.
Okay. B is not congruent to 88.
Maybe it is.
B is equal to 88, but it's not congruent. All right.
Measure of angle B.
All right. So Madison, Ben, I believe the worksheet's already up online. Have you checked?
Yes, I have.
Yeah,
Okay. And their answers are there. Please do it all. It is practice. It's all fairly simply done. You should be done in about 10, 15 minutes total, but please do them all. Especially the ones at vertical angles. Make sure you draw them out so that you don't get confused. All right. There we go. One of them makes the whole screen black so that you can use the whiteboard to draw on it. And the other one, I don't know what the other one does.
I'm going to do very simple.
Oh, I think it just gets out of the presentation.
Laser pointer.
You just did.
Yeah, I want the laser pointer.
Occasionally I do that in algebra. I never do it in geometry, but occasionally I will do it in geometry. All right, Madison, Ben, I'm going to stop the presentation, and we will see you guys tomorrow.
Bye. Have a nice day.
Okay.
You as well.